This video goes out to all the Nick Teutons out there in YouTube land. All right, that song, if you didn't hear it, was sponsored by the guy in the orange shirt who said he'll sue me if I say his name. So, now looking at the homework assignment, if you look at the homework assignment, and yes, I have to repeat this, you'll notice that in 2a, it starts with y equals x squared. And then in 2c, it says x equals y squared. What do you notice happens to the graph when you just switch the x and the y? It flips. Thank you, Nick. And then again, if you look at b, where it says y equals negative x squared, and then you look at 2d, what happens when the x and the y switches again? Flips it on its... Nice job, Nix. All right. Again, if you look at 4, and you see when you started it was y equals 2x plus 4, but then when you do b, it's not as simple as just we flip it on its side, right? There's something a little bit further that we have to look into that. And so today, our whole goal is to look at what happens when you switch x and y. A few weeks ago, we were doing a chapter about inverses. And one of the things we talked about was to solve for the inverse, we would simply switch the x and the y around. And we even looked at the graph. So, when we look at these equations, there is a relationship between them. One, of course, says y equals x squared minus 2x minus 8, and the other one says x equals y squared minus 2y minus 8. So the only difference that you see is that the x and the y are switched around. One option for you is to actually solve it using a format that you're used to, and some of you will find that that's much easier. Another option is for you to switch the x and the y around and just leave it as is, as the question states, and solve it. But obviously, as you solve it, it'll look a little different. So that's what we're going to do. Are you with me, Nick? Great. Okay. Step number 1, whenever we're solving for a parabola, is to find the what? X and y intercept. Nice job, Nick. So x intercept and the y-intercept. The y-intercept is pretty obvious here, right? It's negative 8. We good with that? On this side, if you were to look at this negative 8, it is no longer the y-intercept. It's actually the x-intercept. The difference is because that's where x is. Remember, your x-intercept is when y equals 0, so when you plug in the zeros there, it becomes obvious. Yep, it's the x-intercept that's negative 8. Over here, the reason why it's the y-intercept is because you're plugging in zeros for x's, and that's what gives you that negative 8. All right, now, to solve for the x-intercept, on this problem here on the left, was y equals, we set y equal to 0, and you have to solve that. So we got to factor it. So how do we factor that problem? Positive 2, negative 4. So we have x equals negative 2 and x equals positive 4. We good with that? Then, next step is the turning point. Right? Before I do that, let's look over here at the contrast with this equation. When it says x equals y squared, blah, 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 and you put that 0 in for x this time, and you factor, it will look very much the same, except instead of saying x plus 2, it would say y plus 2 and y minus 4. So when we solve this, again, instead of it saying x's, it's going to say y's. Remember, what you have done is switched the x and the y around. This goes with the solutions as well. All right, same step, turning point. How do you find the turning point of any parabola? Middle of the two x's, or x equals negative b over 2a. So negative b would mean negative negative 2 over 2 times 1, so it's 1. And so I plug the 1 in to that equation, and just for I'm just going to do it for you. You get negative 9. Over here, when you find the turning point, yes, it's still negative b over 2a, but it won't equal the x, it will equal the y. And so, for the same reason over there, it will equal 1, but it's the y value. And hopefully, to no surprise, you would find the x value to be negative 9. Again, your x and y switch. As you graph them, the difference, sorry, I need to look up here. So I have negative 2, I have positive 4, it needs to cross at negative 8. Easy enough, right? You cross to that turning point, you get your y-intercept, it's all pretty easy. The graph here on the right, where it said x equals, instead would be, okay, negative 2 on the y, positive 4 on the y. It crosses on the x-axis at negative 8. And so as you'd expect, it flips. It actually is not just, oh, we're just going to turn it on its side, but is a flip over the line what? Does anybody remember what that is? Y equals x. In fact, if I was to draw the line y equals x and reflect over that line, that's what you would get. So, in your homework packets, just for a quick second, look at number 5, and in particular, letter E. Okay, so in letter E, you're going to notice there's a graph. And in that graph, it has a picture, and I'm just going to, I don't know, I'll draw a makeshift one. I know it's not exactly the same, but let's just say this is our graph. And it tells you, okay, this is y equals f of x. I want you to find x equals f of y. So it wants you to switch the x and the y's around. How do you do that when you don't have the equation? What are you going to do? You could draw the line. Option number 1 is to draw the line y equals x and try to do that. Let's be real. Some of you aren't so good at that. Option number 2, pick points on your graph that you can easily recognize. For example, on yours, you should see one at negative 1, 0. Can you all find that? And so what will happen when you switch the x and the y around, instead of it being negative 1, 0, it would become 0, negative 1. Nice job, Nick. All right. And over here, if I was to look at your next point, you're looking at 5e, the graph that we're talking about, you have a y-intercept. Is that 0, 3? Is that what your graph says? Somebody tell me? Yes, 0, 3. So instead of it becoming or being 0, 3, when we switch the x and the y around, it becomes 3, 0. And do you follow it? What you do there? Excellent. All right. Now, before I move too far away from all this stuff, I want to take another minute and go over a couple of the graphs like you do see in 5. Because sometimes it is easier to look at the original graph, like we did with that parabola, and we looked at y equals x squared minus 2x minus 8. And that was fine. But sometimes that's not easier. It's just easier just to graph it. So let's look at both kinds of graphs. Let's start with this one. X equals cosine y. This is a prime example where, hey, we could just find the x-intercepts. We could set up a table, whatever your method is. Or, in your mind, you could think about, I know what cosine looks like, the actual cosine curve looks like. Is there a way that I can use that knowledge to come up with this graph, x equals? And of course, it would be handled much the same as I was talking about with 5e, where you pick points that you recognize, starting right at the beginning, 0, 1, boom, boom, and do that. How do you know how to draw this? Somebody said they knew how to draw it. It is the inverse cosine. The main clue, how do you know that's true, Nick? Right, you switch the x and the y. So that should be enough of a clue to say, hey, that's the inverse graph. So you actually thought, hey, wait a minute. That's the same thing as the inverse cosine graph, which we have done before. It is. So either method, I don't care. I love it, both of them. Regardless, you're going to end up with, instead of it being 0, 1, it's going to be 1, 0. Instead of pi over 2, 0, it's going to be 0, pi over 2. And once you get a good start on that, hopefully you can draw the rest of that graph. Good? Let's do another one. X equals 2y plus 6. First of all, what shape is this graph? Excellent. It's a line. We have to do the x-intercept and the y-intercept. Do we need to look at what the original graph is? In other words, y equals 2x plus 6? No. We can go right after this and say, all right, what's the x-intercept? That's when y equals 0, and it is 6. Excellent. And the y-intercept is when x equals 0, right? So you plug 0 in, and you solve. And so then we can easily graph this. Just make sure you're very careful at keeping the x and the y straight, because sometimes you'll solve and say, okay, x is 6 and y is -3, but then somehow graph them incorrectly. Does that make sense? Some people they'll place them wrong. Okay, what I would like you to do right now is I would like you to try x equals y squared minus 4 on your own. I'm going to check yours. And then after I've checked it, feel free to go ahead and work on number 5 and 6. But I'd like for you for Monday's class to do numbers 5 and 6 and to watch the video on piecewise functions. Okay?